Good afternoon all of you. So today we will discuss that oscillation chapter. Okay, that is last chapter. Oscillation. See, suppose I am telling this is one spring. Okay, and that is one block of mass m. And here one that is ground, floor present, table suppose. So that is a natural length suppose L. That is natural length. Suppose I want to apply force here. Suppose right side, and I want to release. It will oscillate here.
Yes.
It will oscillate. See, suppose I have one string here and one object here, small object, and that is hinged here, just fixed. I want to apply force here. Initially, tell how many forces here? Sir, tension here, and that mg. But see, I have applied force. Due to that force, that will oscillate now to and fro motion.
Yes.
So that is also called oscillation. Oscillation is to and fro motion. So first, we will write a definition of periodic motion. What is periodic motion? Tell anyone.
Sir, it will move. It's called oscillation.
Means the motion that will repeat itself after one fixed time. Periodic motion. Suppose I am telling Earth revolving. Suppose that is sun. Okay, and now that is Earth, and that Earth is revolving around sun along that elliptical path. After 1 year, fixed na that. After 1 year, it is repeating its path. Suppose you have clock, that wall clock. So that clock is repeating after 12 hours. Okay, got my point? So that is called periodic motion. What is meaning of periodic motion? It will repeat itself after one fixed time. Fixed time, always fixed time. Got my point? So what is the definition of that periodic motion, right? Definition first. This that diagram no need. Okay. Write a periodic motion. Definition. It will repeat after a regular interval of time. I think it is correct now. It will complete after a regular interval of time. Okay. Next. See here, suppose I have one bowl. Okay. Here I have kept one small ball. Small ball. Now I want to oscillate. So it will oscillate here to and from motion. That is also called oscillation. Good. Here suppose one bowl, small m. Initially how many forces? Sir, downward mg. And due to contact normal. Good. Suppose I have applied some small force. It will oscillate now. It will go up to here. It will go here. It will go. Got my point? So that is also called oscillation. Got. Next, I told that Earth's example and Sun. Suppose Earth revolving around Sun after a fixed time. That is also called oscillation example. Okay, this right there.
We draw the diagram.
Diagram draw. See what I'm telling here. That is your curved surface, na circular surface. So you know here, assume a frictionless surface. Why sir friction is straight? See, if of friction percent, if friction percent, see it will resist, means it will see. Initially, suppose it will go up to this now. Due to friction, some energy will loss. So that time, your that movement will slow down now. Firstly, that after slow down. It will stop now. Due to friction, it will stop after some time. But suppose friction not present, so always it will oscillate, not getting, right? Any doubt here? No. Next type, oscillatory motion. See, anyone tell us what is meaning of to and fro? What is meaning of to and fro? See, suppose that is one string, and here one object present, object here, and mass m. Okay, and here I have fixed. I told just I want to apply force. So it will go up to this point. Suppose that point A, that point B, and it will come also. and further it will go here also. That is suppose C. Got my point? So it will repeat itself. That is called oscillation, to and fro, to and fro. Got my point? To and fro motion. So what is periodic motion? It will repeat its path after one fixed time. And what is to and fro motion? To and fro. Got my front back, front back. How you tell all oscillation is a periodic or all periodic is oscillation. Which is correct? Tell. All oscillation is periodic or all periodic is oscillation? That is called, sir, that is oscillation now. Means sir, it will oscillate to and fro. Got my point?
But
Not complete periodic now. Tell. And all periodic is oscillation. This is not correct.
not that.
See, I am telling all this is not correct or correct.
Not correct.
And this is
Correct.
correct. Why? See, here suppose see here all oscillation now. It will oscillate now to and fro, to and fro. See here one fixed. Time current fixed here. You know simple pendulum. Clock we have seen. There one fixed time now. Once that is 2 seconds. That will repeat itself after every 2 seconds. That simple pendulum. That will repeat itself after 2 seconds. Every 2 seconds it will repeat. So time period also fixed here. So that is periodic now, but that is oscillation also. It means all oscillation is periodic. That's correct. All oscillation is periodic. Why, sir? Because for oscillation we want to and fro. And oscillation is to and fro. And to and fro this will repeat after one fixed time. So that is called periodic also. So that is correct now. Not getting. We can ask sir here, sir, all period till suppose we have sun. First thing here, sun. And now second we have earth. And suppose earth is revolving. How you tell that is periodic or that is oscillation? That is periodic. Not oscillation. This. Oscillation is to and fro now. This is not to and fro motion. This is circular motion now. This is a circular motion, not to and fro motion. So all periodic, not oscillation.
It's circular. If it is in circular motion, it is periodic.
Periodic.
Okay.
Not getting.
Okay.
Not only circular. Every many things present here. Not till sir only that circle no.
Okay.
Every curve suppose in elliptical also. That is also correct. Not getting.
Okay.
Got. And see suppose wait. You tell. Suppose I have one square field. That cricket field. Square suppose. And you are running. You are walking. Suppose. And you are suppose this point A. Now you started your this walking now. And after 1 hour you come now here. So 1 hour. Next also 1 hour. So you are repeating your path after one fixed time now. That is also periodic, sir. Periodic, but that is not circular now.
Where the fixed time is there?
Time fixed. You will repeat your path after a fixed time.
Again we will come to initial position.
Initial point. That will be circular also correct, sir. Square also correct. Elliptical also correct. Any correct.
Any part,
But
will
all
come
you
to
have to
initial.
your path, initial and final both. Not getting.
Okay, sir.
What is our oscillation? That will oscillate only to and fro, to and fro, to and fro.
Okay, sir.
Not getting to and fro, right? So here you got oscillatory means to and fro motion. Okay, oscillate to and fro motion, right? Next, write difference between periodic motion and oscillatory motion. So what is a periodic motion till? I am writing, right? The object motion of object. here I have written the motion of object, periodic, that repeats its path after regular interval of time. What? That is called periodic motion. What about oscillation? Periodic motion in which object moves to and fro from a fixed point. In which object moves to and fro. In which object moves to and fro. Okay. Suppose here I have one string, one object, and that is fixed now. Now I have applied force. It will oscillate now. That is called oscillatory motion. But that is called, see, that is spring block system I have. First thing, okay. Here suppose mass m present, that is one smooth surface. So suppose I have applied force, it will now oscillate. That is called what? Periodic or oscillatory? Periodic. And that is called?
Osscillatory.
Okay.
Here time not fixed to here.
Fixed means that is fixed now, no? That is fixed. Not it?
Time not fixed here.
Time here also fixed, but that is to and fro motion. To fro. And periodic is now complete. A complete is which type of circle or square also?
Yes, any
Square, but that will repeat itself after. Got my point? Initial point both equal, is same position. That's called periodic. Oscillating means half, like that, to and fro motion. Not reading it?
full circle, semicircle.
How full circle also. Completed?
Yes, sir. Not completed.
So I told all oscillatory is periodic or all periodic is oscillatory?
All period, all period is period.
Abhi tell one thing. What I told all oscillatory or all periodic?
All oscillation is periodic.
All oscillation is very good. And all periodic is not
Oscillation.
of that spring, that object and string. That is which example? Oscillatory
Oscillatory.
or oscillatory. So this periodic or not? Yes, sir. Because all oscillatory also periodic. Not reading.
Okay.
And all oscillatory also,
Period.
but all periodic at Earth and Sun. All periodic not.
Oscillation.
God. Very good. So this example can write here also. Yes, we can write because it will oscillate not to and fro, to and fro, to and fro.
But
Not
this we cannot write there.
here, see, this is just a. Wait, I am writing another example. Here,
We
that
write
is
this.
Earth and Sun. Very good periodic example.
Sir, we didn't write this.
Don't write here, see, Sun. Then you will. That is Earth now. So which example that is? Sir, periodic. Periodic example, circular, na here. And here now that is a oscillation example. Another is a spring block system here. That is mass m, and that is so that is also two information here. Next write restoring force. Definition. Right first, then I explain. The force
direction in a direction opposite direction.
Acts in the opposite direction.
Sir, clean the direction also.
Right, first thing.
Sir, clean the direction.
This.
No, sir. Opposite direction. Acts in a direction, opposite direction. Acts in a opposite.
Clear? Can I start? Force acting on the particle which tends to bring the particle towards its mean position. Mean means what?
Average.
I know. Mean means here net force 0. Array first think about this problem. Mean means what?
Yes.
If net
Force.
0. Force net 0. So you have written this now. Once I read the force acting on the particle which tends to bring the particle toward its mean position. Wait, see. All of you see here now. I am drawing one that is string, okay, and that is one object present. What my point? Mass of this object m. You tell initially. That is suppose point A. How many forces you tell initially? Sir, first that tension now, and second is very good. So can you tell tension equals to?
Mg.
Sir, net force here 0 or non-zero?
Zero.
Sir, because of what tension?
Balancing.
Balance. So that is called mean position. Not getting.
Okay.
And suppose I have applied some force. It will oscillate now. Suppose, can we clean this thing?
Yes, sir.
Okay. I will see. That is the mean position is known as restoring force. Tell one thing. God. And here see, the restoring force always acts opposite direction of displacement. Returns, I will draw one figure 1 second. Okay. The restoring force always acts opposite. Suppose your block is moving right now. So restoring force opposite. Wait. Here see, mean position, sir. The point at which restoring force on the particle is 0. That is called mean position. And at mean position, you tell means your object not moving. So what is the energy there? Minimum, zero energy. Suppose you are not moving, it means you have no energy. Minimum energy. Good. So that is called your mean position. Completed now? Can I clean now?
Yes, sir.
Wait. See here I am drawing 1 second that string and block. That see. That you told point A. And that how many forces you tell? That is tension. And that is
Mg.
so I am asking if let tell you that is 0 or non-zero. You will tell sir here tension upward minus mg. But both equal actually. Tension mg now. And suppose tension more, so it will go up. Suppose mg more, it will go down. But it is not moving, which means tension equals to mg. Which both equal now. So net force here what? 0 now. So that is called mean position. Got? That is called mean position. Wait. See, suppose this string has length L length. Now suppose I have applied one force, some force. So it will oscillate now. It will oscillate that. Suppose it will present here. After some time, it will present here. Suppose at point B. Suppose. Okay. And that angle, suppose that is theta. Okay. At this point B, then how many forces? Sir, always the tension along the length of string, no doubt. Yes, always. Okay. And always vertically downward mg, downward, not like that. No. Downward mg is there. So that is your mg force. Got my point? I will tell one thing. can we extend that time like that up till that both parallel are checked?
Yes.
It means that this angle and this angle both
Equal.
not getting, sir.
Yes, sir.
God, see, this image has two components, sir. Along this one, what is that called? mg cos theta, and that is called very good. See here, that point B. So can I tell, sir, tension equals to,
mg cos theta.
because you're seeing not cutting the means.
Yes, sir.
This ratio means tension equals to.
mg
Now you tell, suppose your object present here at point B, so it will go further or it will come now?
back.
It will come back. Which force? That
Sin
force.
theta.
That is called restoring force. Because wait, where is your initial position, sir? A. Here initial position now. And you have applied force, it will go up to B now. Here mg two components. First mg cos and second mg.
Sin.
So see, here tension and mg cos both cancel out. Why, sir? Opposite na here.
Yes,
Check that tension equals to.
not go further.
No, it will come now. Due to which force? Due to which force?
mg sin
So
theta.
that force what I told, the restoring force, due to that your particle wants to come toward its initial position. Of that is initial position now. So that mg sin theta is called restoring force. Not really. Now see, here that point B. What I told? Here see that point A now. Here minimum potential energy. Okay, minimum potential energy. I will tell that thing by using spring block system. Okay, you got here now. So I am telling tell what is restoring force. Tell what is value. AF restoring. That is called AF and that smaller AF restoring. Got. And what is this value then? See, AF and D. That is your initial position now. That is initial or final. And that is your. So always initial, you know, we have to use 0, 0. Means that is your 0, 0. And your particle moving like that, not that. Not really, no. So that is called, sir, your final position. Your that mg sin theta along minus x or plus x.
Plus x.
That is 0, 0. So that is now minus x. And that is now.
Plus x.
So your mg sin theta.
Minus
Minus
x.
x.
Minus x. Minus x.
This is restoring force. We have to write mg sin theta or minus mg sin theta.
Minus mg sin theta.
Not really. That is your
Yes,
answer
sir.
of restoring force.
Okay.
Right.
We will draw the diagram.
Diagram though. Equals to mg cos theta at which point? B. And at point A, what is tension value? Tell mg, only mg. Tension equals to? But here tension equals to. Oh, got my point. Tell. Here tension more. A point or B point?
B.
Why?
Again minimum.
Minimum tension. Tension no here. Tell.
Sir.
Completed.
Sir, wait more. Tension.
Tension first.
Okay.
At first, why, sir? Because your particle moving now. That is an oscillation at to and fro. To and fro. Not really. You know one thing. Suppose that is one string now. Here one object now. Suppose it is involving around circle. You will tell, sir, here tension T downward mg and any particle that is moving. So here that is centripetal force. And that is what? That is m v square by r. So if you write here, so you write what? Tension at point A equals to mg plus m v square by out. Here tell here at point A, theta value what? 0 or 90? 0, sir. Are here 0 now. Now your block moving here. So theta increasing or decreasing?
Increasing.
Now you tell if cos theta increasing, cos theta increasing, that are now decreasing, na re? And suppose you have cos 30 and next you have cos 90.
Decreasing.
That is 0 now.
Yes, zero.
It is theta increasing, so cos theta
Decreasing.
that would decreasing na here.
Yes, tension.
So tension always at lowest point
Is
more.
more. Okay, sir.
Lowest point more. Okay.
Understood.
What I point?
Yes, sir.
Hey, not completed. Don't know of oscillatory motion, right? So what is definition? Tell. To and fro motion. Okay, to and fro motion. See, I'm telling one thing. So I'm telling, okay, tell Newton's second law. What is the equation of Newton's second law?
F equals to mx or dv by dt.
D by d is equals to F, not there. Here I'm telling, okay, tell now oscillation motion equation. So here now write restoring force. It always restoring force. So Fr equals to minus kx power n, right? And you tell what is that Fr? That is called restoring force. Right.
Constant k.
Restoring, right? I will tell. Restoring force. And that x is called displacement. Okay. This is got my point. And that is called constant. One constant. You know, spring has what is force? Kx not there. K is what? Spring constant now. That constant K here. And what is n value, sir? N value tell. N value? That n value equals to always odd number. 1, 3, 5, 7 like that. Okay, that is called oscillation. I will tell why odd number only. But no need to that. Okay, 1, 3 remember. Got my point. So see, oscillation what? To and fro motion. What is equation? If r equals to minus kx power. Or see, if n equals to 1, put 1. What is restoring force?
If r equals to
Minus kx
power 1.
Power 1. Got. So that is called simple harmonic motion. And in your syllabus, you have to read only simple harmonic motion. Simple harmonic motion. N equals to 1. Once again tell, what is periodic motion tell?
Periodic motion.
It will repeat itself after one fixed time. Example tell. Sun and earth. Okay. And what is that oscillatory motion?
Pendulum.
Pendulum or to and fro motion. I am telling you, all periodic oscillatory or all oscillatory periodic?
All oscillating period.
But all periodic not?
Oscillating.
What? Next I told about oscillatory motion, to and fro motion. And oscillatory motion, what is that? Okay, what is restoring force, sir?
Restoring force.
Due to that force, your particle wants to come back to its
Initial position.
suppose I told here, suppose tension, block, small object here, mg downward, tension upward. So it will go now here. Here tension, now mg cos not there. So tension equals to mg cos. And mg centered like that. So due to mg centered, your particle wants to come toward its
Back position.
So what is restoring force?
Restoring force.
Plus or minus?
Minus mg.
Why minus?
It will come back with negative y and minus x.
Negative y, is not that? That is origin, that is positive, not there. Negative. What? So restoring force equals to minus k.
Minus
mg sin theta. Okay. Wait. Next I told oscillator motion equation. Sir, minus restoring force minus kx power n. God. Now you tell that is restoring force. That n is what? Odd powers.
Odd numbers.
Here no need, so I am skipping that. No need in your syllabus. Why odd only? Okay. But JE given that question there. Okay. Always odd. Wait. I told n equals to 1. That is called simple harmonic.
motion.
That is called simple harmonic. Good. What my point?
Yes.
So right now we have in your syllabus you have to read now about simple harmonic motion. N equals to 1. I am asking tell what is the force value. You will tell what? Minus kx now.
Minus kx
And
power
suppose you know spring also spring. What is force value tell? Sir, force equals to minus kx.
Minus kx.
Now that work power energy. Check minus kx now there.
X power 1.
This we have to now remember. Restoring force equals to minus k into x, right? See, that is one object. Okay. I will tell. Suppose I am telling that is which mean or mean position, that is na?
Yes.
Mean, that is suppose A, and that is called mean position. You know, we have two position, mean and tell.
Yes.
That is now suppose B position, that is A position. Okay. And that angle is theta, suppose theta. You know, suppose your that is which periodic or oscillation? That is, arey B.
That is oscillation, sir.
Oscillation.
Yes.
Okay, oscillation.
Uh,
Oscillation.
Yes.
Now you tell, oscillation I told there are two types of oscillation. First simple and next non-simple. First is simple harmonic motion.
What is simple?
Now see, I told oscillation, tell the definition, sir. Oscillation means minus, tell here, minus a x or n, sir. Oscillation. But suppose I tell about simple harmonic motion, that is now restoring force equals to minus a x power 1. So only this is okay, simple harmonic motion 1. And suppose you want to keep here 2, that is not simple, that is different harmonic.
Only one.
So I cannot tell, in oscillation there are two types of oscillation. First simple and second non-simple. That is not. So simple, what is how can I identify simple?
Minus
1,
k
n equals to 1 there. Here 1. And suppose n equals to 2. That is not simple, that is different now. Got my point? I will tell, that is oscillation now. Yes, oscillation, oscillation 2 parts. Simple harmonic motion also present there. So see, what is problem? This theta suppose less than equals to 10 degree. Okay, see what I am telling. Wait. If theta less than 10 degree, then it is called simple harmonic motion. Otherwise, it is called non-simple harmonic motion. See, suppose that is object here, and it is rotating now, oscillating. Okay, so that is periodic or oscillation. Oscillation, sir. And all oscillation is
Periodic.
this is periodic also, na?
Yes.
Not rotating.
Yes, sir.
But suppose that is Earth, now it is revolving around sun. That is periodic. So all periodic oscillations no.
But all is oscillation.
What my point?
But sir, it is also completing full
Yes,
circle,
so
no?
that is periodic.
First it is following oscillation and completing circle.
Arey, that is completing now. That is called periodic. It is not to and fro. Oscillation is to, fro. Pendulum. So once again repeat, all oscillation is periodic. And all periodic
Not
oscillation. And oscillation two parts divided further.
Simple
And non-simple. So simple means okay. What is oscillation definition? That means formula minus a is for n. And I am telling n put the 1. That is now simple harmonic motion. And suppose you want to put 2. That is not simple. That is different now. Got my point? So can you tell that is oscillation now? That is simple harmonic motion also. And simple is oscillation now. So here theta value 10, less than 10. Got my point? Suppose that is called simple harmonic motion. That is in a short you can write SHM also. Simple harmonic motion. Got? See, suppose you have a string and that is object present. Okay. And now I want to apply force. So this will go up to 60 degree. Suppose 60 degree. You tell that motion is here 60, here 60 nothing.
Yes.
That's 60. Abhi tell that is simple harmonic motion or not? No sir.
Oscillation.
Only it is called oscillation, but not simple harmonic motion. But this is called sir
Simple harmonic.
and oscillation also.
Means sir, degree should be only 10.
10 is small degree actually.
Sir, how much this will go? That also same.
No. Actually this is here. See theta value very less na. I have drawn here, but a very small theta. See that is now this theta this.
Okay.
Theta very small. That is called what? Simple harmonic motion. And that is no.
Non-simple.
Not
That
very.
is non-simple, no?
Non-simple. What my point is because theta very large, no? Large here. Got? And that is simple. Why sir? Because
Theta less, sir.
theta very less. I think you got all clarity here. Got all clarity now? Tell.
But okay, please.
Got now? Right this.
Sir, if like that is
Now write always now I will write I will not write simple harmonic. I will write SHM. Simple harmonic, that is short word, no? Simple harmonic motion. Okay. String and point mass. See, here derivation you will get in IP also. This derivation. Okay. Here one small mass, small m. Okay. And here that is tension T. That is now mg. And I told suppose you want simple harmonic, so that angle is very small now. Means that is suppose point A. Now that is point B. Very small. What my point? And that is less than 10 degree. And that is a point B. Here two forces, tension and mg cos theta. And that is mg Sin theta, very good. Now I'm asking tell what is the restoring force? You will tell if R equals to minus mg sin theta. Now you see, if theta very small, okay, if theta very small, see here, that length is what when first that length is L. What happened? And now see, that small curve, that is A, that is B. That small curve now, small curve you can treat as a straight line also. Straight line.
Okay.
Not really, no?
Okay.
I told you that small curve, sir, small. Because it will go like a small curve now. It will big, okay. Small, that is small, very small. So very small, that is treated as a straight line. Got my point? So that straight line assume our length is L. Got my point? Straight line assume length is L. Very good. Tell if theta very small. So you know one thing, sin theta equals to theta only. Now don't this thing. If theta very small, so sin theta behaves like a theta. Got? And that is also behaves like a tan theta. Got my point? Very small. Then you can got. Suppose I am asking sin 30. What is value tell sin 30? That is 1 by 2. So that is 30 or more. But suppose I am asking tell sin 2 degrees. Suppose t. What is value, sir? 2 degree. Tell what is value? Sir, we know sin theta equals theta now. Sin 2 is now 2. But see, 2 is degree now. So convert into radian.
Okay, you're right.
Got my mind? Just this right here. Got my mind?
Okay, sir.
Here also same thing. So sin theta equals to theta now because theta very small. Now here put the sin theta equals to theta. Tell what is value? Wait. What is force formula? Force equals to MA. Got? Force equals to MA. So can you write here that is mass into acceleration equals to minus mg and that is theta. Very good. Got? This mm cancel out now. A is what? Minus g theta. Got? First write this. Anyone tell here, see here, that is your L length na here. So that is L, that is 90 degree check. And that is L length. So what is tan theta will tell? Equals to x by
L.
not reading.
Yes,
And I
sir.
told check that is perpendicular na here.
Yes.
That's hypotenuse. Now tell us tan theta we can write theta also.
Yes.
Equals to x by
L.
this will put there. What you get? A equals to
Minus G.
L by x. Now see, I told that time for Osscillation, simple harmonic motion. What is force? That is a minus k x power 1. Here also power 1 now. What happened? And that is called one constant. What? See, G is constant or variable? G constant or variable?
Constant.
Here also
Constant.
constant. It seems A is a directly proportional to minus x. That is the simple harmonic motion. Means that is called simple harmonic motion. Okay, all of you?
Sir,
Tell me.
so see, you explain.